3 days. That is the interval between the moment the FAA closed the investigation into an earlier Raptor incident and the moment Flight 13 stood on the launch pad. 3 days. Then 4 of 33 engines failed to ignite. This is not the first time this Raptor line has run into trouble. It is the second time in under 2 months. This same week, NASA released a new plan for Artemis 3. These two things happened right next to each other. Is that a coincidence? I will take apart every detail right after this. I'll start with the half the title already promised you. The same week Flight 13's launch was scrubbed, NASA released new details of the Artemis 3 mission architecture. I need to state this clearly up front, so there's no misunderstanding. These two events occurred at the same time, but there is no evidence that the Flight 13 incident caused this announcement. These are two parallel developments, not a causal relationship. And there's one point I need to clarify right here because it's the single most misunderstood detail in this whole week's story. Per NASA's announcement for Artemis 3, the SLS's ICPS upper stage will be dropped entirely. In its place, a non-propulsive spacer block. They're purely to preserve shape and mass. It will be the Orion spacecraft's own European service module that performs the orbit-raising burn. The first time this module has had to do that alone on a crewed mission. As for the burn that sends the craft toward the moon, the TLY, the one Starship is meant to perform, NASA confirmed. That role belongs to Artemis 4, not Artemis 3. So what does Artemis 3 actually do? This is the rehearsal portion. Orion will dock and turn with both experimental landers, Blue Origin's Blue Moon, and SpaceX's Starship, while still in low Earth orbit. Per NASA's announcement, the Blue Moon spacecraft will be fully outfitted with crew-rated systems, cockpit, life support systems, avionics. NASA also stated this vehicle will carry an Axiom spacesuit fitted with sensors, functioning as a human mass simulator. Starship, for this particular mission, will carry no cockpit. NASA's explanation: the objective here is not to test Starship's ability to carry crew. It is to assess how the entire assembly behaves once Orion has docked with each vehicle in turn. And here's the detail I think matters most. NASA confirmed that Artemis 3 will test the ability to hand off software control between spacecraft. While docked with Blue Moon, Orion's software governs the whole stack. But once docked with Starship, control authority shifts over to Starship's own software. This is precisely the rehearsal for the exact moment Starship will perform the real TLI burn on Artemis 4. Verified here in low Earth orbit, where a failure only means an aborted test, not the loss of a crew partway to the moon. In other words, Artemis 3 does not hand Starship the TLI role outright. But it is the mandatory stepping stone NASA needs before it can have enough confidence to hand over that role on a subsequent mission. Not only that, Orion is also getting a notable communications upgrade. During the Flight 13 countdown, NASA and SpaceX announced that the agency has selected 2 Starlink laser communication terminals to equip Orion. These mirror the system SpaceX previously used on Crew Dragon during the Polaris Dawn and Fram-2 missions, delivering gigabit-class connection speeds and markedly higher quality live video. But this is not the first time Orion has used laser communications. The spacecraft already carried an experimental optical communications laser on Artemis 2, which communicated directly with ground stations and proved to be of considerable value. So there. That's the second half of this week's story in full. But the first half of the title, what actually caused Flight 13 to be scrubbed, is far more complicated. And that's the part I really want to dig into with you. The forgotten precedent, Flight 12. To understand why this detail matters, I need to take you back 1 month. To be exact, May 22nd. That's the day Flight 12 flew. At that point, after Starship separated from the booster, Super Heavy executed a maneuver called the flip to reposition itself for the return flight to the landing point. This is one of the hardest phases of the entire flight because the booster must rotate with precision while still hurtling forward at tremendous speed. At that exact moment, 5 of 33 engines failed to relight as planned. Picture it like this: a multi-wheeled truck, and 5 of those wheels suddenly lose their brakes at once. The truck still comes to a stop, but it is no longer on the trajectory you wanted. That is precisely what happened to Super Heavy. The boostback burn ended earlier than planned. The booster lost the ability to control itself for landing in the Gulf of Mexico. The incident was serious enough that the FAA was required to open a formal investigation, a mandatory step under regulations that apply to every U.S. commercial launch whenever an off-nominal event occurs. For the duration of the investigation, SpaceX was barred from flying any further Starship flights. That investigation closed on July 13th, exactly 3 days before Flight 13. According to the official findings, compiled in full by the in-depth technology outlet The Register, there were 2 root causes behind the Flight 12 incident. Cause 1, thermal effects acting on components of the propulsion system during ascent. Cause 2, a configuration error in the engine warning system, which caused it to misread signals. An engine could have still been operating normally, but the monitoring system read it as faulty and intervened automatically. If Flight 13 were the first time a Raptor engine had ever run into trouble, you could reasonably treat it as a random, isolated event, nothing to worry about in the long term. But set it alongside Flight 12, where 5 engines also ran into trouble during restart on this very same Raptor line, and the picture looks entirely different. The data suggests these may not be 2 fully separate incidents at all. It is quite plausible that they are 2 different expressions of the same underlying problem, a reliability issue with the Raptor engine, specifically when it must start or restart under extreme pressure and temperature conditions. The arithmetic behind the 2 incidents. Let's run a small calculation. 5 engines in Flight 12, 4 engines in Flight 13. Out of a total of 66 required engine starts or restarts across the 2 flights, 9 ran into trouble. That works out to a failure rate of roughly 13%. On a system where a single engine drifting off timing by mere thousandths of a second can throw the entire cluster off balance. This figure calls to mind an old episode in rocketry history. The Soviet N-1 program in the 1960s likewise used a cluster of 30 engines on its first stage. All 4 test launches failed, and much of the cause traced back to the sheer complexity of coordinating that many engines at once. This isn't meant to equate SpaceX with a program that's been dead for half a century. It's meant to make one thing clear. The problem of synchronizing dozens of engines simultaneously has never been fully solved by anyone at this scale, anywhere in the world. SpaceX is venturing into territory that rocketry history itself has flagged as extraordinarily difficult. Now let me explain briefly why igniting that many engines at once is so difficult, because this is the root of both incidents, Flight 12 and Flight 13 alike. Picture trying to light 33 lighters at the exact same instant. Each one needs the right amount of gas, the right pressure, the right spark, all within essentially the same split second. Let just one drift off by a few thousandths of a second, and the whole system can be thrown off balance. Here is where the 2 cases differ. In Flight 12, that lighter had to relight in midair, after already having endured the extreme heat of the initial ascent phase. In Flight 13, the failure occurred right on the pad, before the engines had experienced any flight-induced stress at all. And this is worth paying close attention to, because it is actually a more encouraging signal than a worrying one. Probabilistically speaking, the likelihood that this is an assembly defect or an isolated sensor fault is higher than the likelihood of a systemic design flaw, precisely because the operating environments in the 2 flights were entirely different. If it does turn out that 2 different stress environments produce 2 different failure modes, then perhaps these 2 incidents are more independent of one another than I initially assumed. But this remains, for now, only probabilistic reasoning. A firm conclusion still has to wait for the official technical report. What SpaceX had already prepared for. One thing deserves fair credit here. SpaceX did not simply sit still after Flight 12. According to the Starship-focused outlet NASA Spaceflight, Booster 20, the very booster whose flight has just been scrubbed in this latest incident, had been physically modified relative to prior boosters. The booster's forward dome received an additional layer of thermal protection to withstand the phase known as hot staging, the moment the upper stage ignites its engines while still attached to the lower stage. More notably still, SpaceX added a reinforcing panel at the exact location where an earlier booster, Booster 18.3, had previously been dented during a pressure test conducted back in January of this year. In other words, SpaceX knew precisely where the structural weak point lay and proactively reinforced it ahead of this flight. That deserves to be acknowledged fairly. This is not the picture of a company that ignored the lessons of the previous flight. This is the picture of a team that read the investigation findings closely, identified the correct weak point, and acted on it before being forced to. But precisely because of that, the story becomes even more worth digging into. If the weak point behind the Flight 12 incident had already been so thoroughly reinforced, then why did the engines still run into trouble at ignition on Flight 13? Based on everything the data currently shows, there are two plausible scenarios, and each one leads to a completely different outcome for the schedule ahead. Scenario 1. Two independent problems. The two flights represent two entirely different operating situations. One a mid-air relight following thermal stress, the other a first-time ground-level start. If that is indeed the case, this is most likely an isolated localized fault specific to Flight 13 alone. Under this scenario, the early next week target Musk gave is entirely plausible. Scenario 2. A shared root cause. If the true cause does not in fact lie in the booster structure, the very thing SpaceX just reinforced, but instead runs deeper into the design or manufacturing process of the new generation Raptor engine itself, then reinforcing the outer shell will not solve the underlying problem. Under this scenario, the early next week target is likely to keep slipping. There is one very specific signal that will let you tell these two scenarios apart. Once SpaceX's next technical report is published, watch closely for whether it repeats the exact same phrasing that appeared in the Flight 12 investigation's conclusions. Specifically, thermal effects on the propulsion system, or engine warning system. If those phrases resurface, that is a clear sign the two incidents share a common root cause. If you want to know exactly when that technical report comes out, and I'll read every line of it to break it down for you, hit subscribe on the channel right now. When the market reacts faster than the news. Now here's a detail almost no one has noticed, yet it reveals just how much real tension surrounded this flight, even before the engines ran into trouble. Per CNBC and NBC News, on the very day of the launch, SpaceX stock closed below its IPO price for the first time since the company went public back in June. Shares fell more than 3%, closing at $131. After the launch was scrubbed, the stock kept falling, dropping to around $124 in after-hours trading. In the past, a scrubbed Starship launch was simply an R&D cost. No one lost revenue over it in real time. This time is different because this was the first flight carrying operational third-generation Starlink satellites. Every day of delay is no longer just a technical delay, it is a delay to a real slice of SpaceX's actual revenue. This may well be the first time a Starship launch scrub has had a direct line to cash flow, and the market reacted almost instantaneously. That puts SpaceX in an unprecedented position. The move fast, fix fast culture, once treated as simply normal in commercial spaceflight, is now playing out under the eyes of thousands of investors, each one reacting with real money to every single delay. If you've been wondering why Musk's statement this time was shorter than usual, just a single sentence with no lengthy explanation, this may be part of the answer. Every public remark he makes now carries the potential to move the stock price directly. This is an angle that very few other Starship analysis videos touch on, because most channels focus purely on the technical side, overlooking the fact that this program is now operating under two pressures running in parallel: technical pressure and capital market pressure. There's something you need to understand to see why SpaceX is willing to wait, rather than rushing to fly again as soon as possible. This flight is not simply an engine test. This is the first time Starship has carried 20 new generation version 3 Starlink satellites, genuinely operational satellites, not the mass simulating dummies used across the 6 previous test flights. Each one is capable of transmitting data to the ground 10 times faster than the current generation, and uploading data 22 times faster. If the current generation of Starlink is like an ordinary household water pipe, this new generation satellite is like a large caliber fire hose. 6 of the 20 satellites are additionally fitted with a special camera system, tasked with scanning Starship's own heat shield and transmitting that footage back to the engineering team within the roughly 20-minute window before re-entry into the atmosphere. These satellites are not merely cargo. They double as a miniature film crew, recording the very health of the vehicle carrying them. And this is precisely the real reason SpaceX has accepted the delay. If the ship were to launch only to have the engines run into trouble at a later stage, the sole opportunity for these 20 satellites to prove out this new connectivity mechanism would be lost entirely. The cost of a few days' delay is far smaller than that price. So, we have two independent stories unfolding in the same week, yet both pointing to the same thing. NASA's long-term bet on Starship does not appear to have shifted just because of one imperfect test. NASA is still building step by step toward the moment Starship truly takes the controls for the single most critical burn of the entire mission. But the real question still worth sitting with lies ahead of us, because there is one very specific signal that will tell us precisely whether this was merely a small, isolated fault or the sign of a deeper problem still waiting to surface. The real answer still lies in the upcoming technical report. Thank you for following along with the Space Brief through this analysis. If you found it useful, give it a like, share your take in the comments, and subscribe to the channel. Related videos are waiting for you right on this screen.